everyone! On this video, we will discuss logic and incidence geometry. At the end of this video, we will be able to prove stated assumption with theorems and proofs and with reductio ad absurdum RAA hypothesis on geometric problem. In informal logic, the logic rule 0 says that no unstated assumption may be used in a proof. The rule says that if the argument's reasoning is clear or obvious for the audience without the flow of proof, it cannot be used in proving. So here is the theorems and proofs that are used in proving statements. Since all the mathematical theorems are conditional statements with the if and then statements, whereas if is the hypothesis, then statement is the conclusion, and whereas the axioms are the hypothesis and the theorem are the conclusion. Proving triangle congruence is an example of the theorems and proofs in reasoning. Example 1. Given that O is the midpoint of segment HA and angle 1 is congruent to angle 2. So let us prove that angle 3 is congruent to angle 4. First, let's have the column proof, the statements and the reasons. First statement is O is the midpoint of segment HA, which is given. So based on the first statement, if it is on the midpoint, meaning the two segments here is congruent. So we will use it as the next statement. Whereas segment HO is congruent to segment AO. That is by the definition of midpoint or by the midpoint theorem. Let's put up the other given, which is angle 1 is congruent to angle 2. Now we have two parts that is already congruent, which is the one side and an angle. So we will be needing one more part to go so we can prove that this statement is true. We can make use of angle COA is congruent to angle SOH since they are vertical angles. So the reason is the vertical angles are congruent. They are called vertical angles because each of the pairs of the opposite angles are made by these two intersecting lines. Can we say now that the two triangles are congruent? Yes. So let's put triangle COA is congruent to triangle SOH by ASA congruence postulate. We have proved that the three parts of a triangle is congruent, then all its corresponding parts is also congruent. So we can conclude that angle 3 is congruent to angle 4 by the corresponding parts of congruent triangle are congruents. Next example is proving a reductio ad absurdum hypothesis. In this type of proof, we want to prove a conditional statement and begin by assuming the contrary of the conclusion we seek. So we call this contrary assumption the reductio ad absurdum hypothesis. So in the figure, AB is greater than BC. Now, we will be making a conclusion which is opposed on the idea of the statement. So how can we make it? Let's make an assumption. So, if we assume that the measure of angle A is equal to the measure of angle C, it follows that AB is equal to BC. It's because if the measure of the angles are equals, then its sides are also equal. So this contradicts the given statement that AB is greater than BC. So what conclusion can be drawn from this statement? So therefore, we can conclude that the measure of angle A is not equal to the measure of angle C. So the contradiction statement that we made is wrong and the original statement is correct. So that is how proving works. Thank you and see you on the next video.